Okay, here is our second example. We're solving systems of linear equations with elimination, remember. So this one looks a little bit different. Notice there's fractions in our top equation. When I run into something like that personally, I like to just remove those fractions and kind of see where we're at. So we can do that if we identify a common denominator. In this case 3, 6, 3. It'd just be a 6. So I'm going to multiply 6 through that top equation, and let's just see what that does for us. So similar to that last one, I'm going to take 6 all the way through, and then I'll write it underneath our second equation here. So 6 times 2/3, that would be 12/3, so that would be 4x. Remember, we're distributing all the way through, so 6 times 1/6, of course that's just going to be y, so 1y. And 6 times 2, that's 12/3, and that is 4. Notice what we've run into here. We have the exact same two equations. So if we subtracted one from the other, of course, they're going to go away. We would get 0 equals 0. Well, that tells us this is a dependent system, so there's an infinite number of solutions. So infinite solutions, but remember the way we're going to write that is still as a ordered pair. It's just going to have variables in it. So our x could be anything. The y, though, still depends on what x is. So if I solve for y in one of these equations, of course they're the same equation, I would just subtract my 4x over. So y would equal 4 minus 4x. So my x could be anything. My y value will be whatever x is, depends on what x is, 4 minus 4x. And so that is the way I'm going to write my solution for this dependent system of equations.